Questions 11 through 20 on the 2004 Grade 10 AMC 10B. Two 8-sided dice each have faces numbered 1 through 8. When the dice are rolled, each face has an equal probability of appearing on top. What is the probability that the product of the two top numbers is greater than their sum? So basically what they're saying is that if you've got a dice and you roll it, and the first time you roll it you get a number A, and the second time you roll the dice you get number B, then AB, which is of course the product, has to be greater than the sum, which is A plus B. So let's start off with a little bit of a scenario here. Let's say the first number is 1, the second one is 1. AB therefore is 1, A plus B is 2. Is this one of our possibilities where AB is greater than A plus B? Well, no, AB here is 1, then A plus B is 2. Similarly, if you have 1 for A, and no matter what you have for B, this will not work. So as you can see, all of these scenarios right here unfortunately do not satisfy our condition. Okay, no problem. Let's try A equal to 2, and let's see what we get for 2, 1, 2, 2, and so on. Well, for the first one, A times B will be 2, A plus B will be 3. For the next one, it'll be 4 and 4, and then for the next one, it'll be 6 and 5, and so on. And which of these is the condition met and which of these is the condition not met? Well, I'll circle the ones where it's not met, those two. But everything else, it works. This is indeed greater, greater, greater. So we're going in the right direction here. Let's use another scenario where we have 3 now. And in this one, you'll see that the only one that doesn't work or meet our condition is the first one. But all the other ones are fine with regard to the product being greater than the sum. And we'll do one last one for 4. And when you make the table for 4, again, the only one that doesn't work is that one. Everything else works. So I hope you see a pattern here. The only time our condition is not met is when you have these unfortunate 1s in here. Anytime you have a 1, it's not going to meet our condition. And these one other, and that was when you have 2 2s. So 5 1, 6 1, 7 1, 8 1, these are also going to result in our condition not being met. So now we just have to add up all of the ones. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 where the condition is not met. All right, and what is the total? Because we have to figure out a probability. The total is going to be, of course, 8 times 8, and 16 is when it's not met. That's how many that didn't meet our condition. So 8 times 8 minus 16 will be in the numerator, and 8 times 8 will be the denominator, and therefore this becomes 48 over 64, and in lowest terms that is 3 over 4, and therefore number 11, the answer is C. An annulus is the region between two concentric circles. The concentric circles in the figure have radii B and C, with B greater than C. Let OX be the radius of the larger circle, let XZ be the tangent to the smaller circle at Z, and let OY be the radius of the larger circle that contains Z. A is XZ, D is YZ, and E is XY. What is the area of the annulus? Well, the area of the annulus is pretty straightforward. It's just pi r squared, the big circle, minus pi r squared of the small circle, right? Take the area of the big circle, subtract the small circle, and that will give you the area of that shaded region. Now the big circle, the radius they give you is b right here. So put that in there, b squared. And then the small circle, that radius is here, it's c. So put that in there, and there you go. We've got pi. I can factor out the pi if I need to. And that is b squared minus c squared. And that's about as far as I can get, right? But that's unfortunately not one of the answer choices. Okay, no problem. I see a relationship here. This triangle right here. That triangle is a right triangle. They tell you that. Even if they don't tell you that, you know, because xz is tangent. And anytime it's tangent, it creates a right angle like that. So using that, we basically get that a squared plus c squared is equal to b squared. And if you isolate for a squared, you'll get b squared minus c squared like that. And this looks very familiar, doesn't it? It's right here. So substitute that for a squared, and there you go. You've got one of the answer choices, and that answer choice is A. In the United States, coins have the following thicknesses. Penny is 1.55 mm, nickel is 1.95, dime is 1.35, a quarter is 1.75. If a stack of these coins is exactly 14 millimeters high, how many coins are in the stack? So 1.55 times p representing the number of pennies, 1.95 times n representing the number of nickels, 1.35 times dime, and 1.75 times quarter. And this total is equal to 14. So we just have to do trial and error. And on the math contest, this is what I call a time drainer. We only have 75 minutes to do 25 questions, and we have to drain our precious time with this trial and error. So I looked at this, and the first thing I did was add them all up, right? I said, if I add up this, does it help me? And unfortunately, it didn't really give me a helpful value. So I looked at anything that kind of looks like it might be a multiple or divisible, you know what I mean? Like goes into 14. And when I did that, I quickly figured out that 14 divided by 1.75 works. 14 is indeed divisible by 1.75, meaning it does indeed give an integer value. And that value is 8. So basically, if you had 8 quarters, and that's all you had, 8 quarters times 1.75 mm would give you 14 mm. And that's it. So 8 quarters is basically how many coins we have. So number 13, the answer is B. A bag initially contains red marbles and blue marbles only, with more blue than red. Red marbles are added to the bag until only 1/3 of the marbles in the bag are blue. Then yellow marbles are added to the bag until only 1/5 of the marbles in the bag are blue. Finally, the number of blue marbles in the bag is doubled. What fraction of the marbles now in the bag are blue? So we've got to create some mathematical equations to illustrate all the information they gave us in the question stem. So initially you've got red and blue, and they tell you that there's more blue than red. And then the very first thing they do is they add a certain amount to the bag of red. We don't know how many, so I'll just say X represents how many additional red marbles. And then our blue marbles remain the same, but they tell you now that the number of blue marbles is 1/3. Okay, so that means that blue over R plus X plus blue is equal to 1/3. That's my equation. So from this we can get several relationships. We can cross multiply and get 3b is equal to R plus X plus B. Okay, hopefully we'll use that later. We can see. And then the next thing that they do is they say that they have some yellow marbles added to the bag. Okay, so now I've got to introduce yellow. My red is still the same, r plus x, and my blue is still the same. When they do this, the number of blue marbles are basically 1/5. So that means blue over all of these guys now, y plus r plus x plus blue is 1/5. Correct? Now at this point, what do? We can cross multiply. Let's see if, later on what we get will be helpful. 5b is equal to y plus r plus x plus b, like that. And then finally, they tell you that they double the number of blue marbles. So that means y remains the same, r plus x remains the same, but now we've got 2b. And they want you to figure out the fraction at this point, 2b over y plus r plus x plus 2b. What is this equal to? Okay, so I've got to figure out the actual numerical value of this. Well, 2b over all this, right? This is where we need to use some of the information we got up here. Let's see, anything that helps us? I think so. Right here, this will help us. So the bottom, I'm going to first break it up into b plus b. That 2b, I'll just break it up a little bit. And if I do, it'll be a little bit more clearer. Now, look at this right here. Y plus r plus x plus b. It is equal to 5b, correct? As we did previously. So I'll put 5b there. And then I've got one extra b, don't forget that one. And then this becomes 2b over 6b. The b's cancel, and I got 2 over 6, which is 1/3. So there you go, that's the ratio at the very end. And therefore, for number 14, our answer was 1/3, and that would mean number 14 is C. Patty has 20 coins consisting of nickels and dimes. If her nickels were dimes and her dimes were nickels, she would have 70 cents more. How much are her coins worth? So initially, she has nickels and dimes, and the number of nickels plus the number of dimes equals 20. And then, since a nickel is 5 cents and a dime is 10 cents, this is her initial value, and I'll just represent X as that since I don't know. Then they're saying, they're doing a switcheroo here. They're saying if her nickels were dimes, okay, and then her dimes were nickels, like that, now you have 70 cents more, so X plus 70. So this is the system of equations that we have to solve, and we want to get the value for X. All right, so here we go. What can we do? I think maybe if we add them, it might help. So 5n plus 10d plus 5d plus 10n is equal to 2x plus 70, like that. Let's see, what does this become? 15n plus 15d, I believe, equals 2x plus 70. And I can factor out a 15 and I get n plus d. Now n plus d is up here, it's 20. So I'll put that in there. 20 is equal to 2x plus 70. So 15 times 20, let's see, bring the 70 over and then divide by 2, and that'll be x. And if you do the math, you'll get x is equal to 115 cents, because I was working with cents. 115 cents is basically $1.15. So number 15, the answer is A. Three circles of radius 1 are externally tangent to each other and internally tangent to the larger circle. What is the radius of the larger circle? So here is our diagram blown up a bit. And I'm going to draw some lines that hopefully will help us. So the first thing I'm going to do is draw basically a line from the centers joining each other like that. So approximately here, approximately there, and let's join that up like that. Okay, so that joins the centers of the 3 smaller circles. And then I'll draw other lines to the tangent points from the centers like that. And then one final line from the center to that point right there, which is basically a tangent point between 2 of the circles. Okay, and let's start labeling what we know. So we know that the radius of the circle is 1 right here, those smaller circles. So that means this is 1, 1 here, 1 here. A lot of these are 1s, so that makes it helpful for us. All right, all of these radii are 1. Now, at this point, what do you want to do here? Which direction do you want to proceed? Well, I'm going to draw a center point of the big circle. I think that center point is approximately there. Now, from that center point, I'm going to draw a line to the center point of one of the other circles. So something like this. Right there, that red line. Now, that red line needs to be labeled. But how do I label that? What is it? Is it r? Is it the radius of the some circle? Well, not quite, but I'll show you what is r. The radius of the large circle, I'll call it large r. It's from here all the way till here, correct? If that red dot represents this red dot here, if it represents the center of the large circle, if I draw a line from it all the way to the edge, that's radius of the large circle. But this region is 1. So that means that red line is r minus 1. Okay? So that is how we label that red line. And in a very similar way, I have to label other segments of this triangle. The first one is here, from here to here. Now I have no clue what that is. I can't figure that out in terms of 1 or r, so no problem, I'll just call that x. And then the next one is right here. This section right there, what is that? Well, from the center of the big circle all the way to the edge, that's the radius, right? So that would be big R. But the distance from here to here is already 1. So this segment in here is basically big R minus 1. So like this, minus 1. All right, and this is of course a right angle in here because it's a tangent. So I hope you can see we've got enough information to create some Pythagorean relationships. So first let's concentrate on the small triangle right there. From that you'll get x squared plus 1 squared is equal to r minus 1 squared. And the next one is the bigger one, slightly bigger one. And from that one you'll get r minus 1 plus x squared plus 1 squared is equal to that length, which is 2 squared. Okay? These are our two equations that we will solve. So first I'm going to start with that guy. X squared plus 1 is equal to r squared minus 2r plus 1. The 1's cancel, and therefore I just get x squared is equal to r squared minus 2r. And I think that's about as far as I can go. So now let me turn my attention to that one. R minus 1 plus x all squared is equal to 2 squared, which is 4, minus 1, and that will be equal to 3. Okay? And if you want to, you can take the square root of this side. R minus 1 plus x will be the square root of 3. And therefore we can isolate for x root 3 minus r plus 1. And I think that's it. So now we've got one variable in terms of another. We've got one equation that involves those two variables. Now we can substitute and solve. So for this equation, I will substitute the value of x equals root 3 minus r plus 1. So I've got root 3 plus 1 minus r all squared is equal to r squared minus 2r. Correct? And now it's a lot of algebra here, but hopefully not too much. So let's see, we've got to expand this. So we've got root 3 plus 1 squared minus 2 root 3 plus 1 r plus r squared is equal to r squared minus 2r. r's cancel, r squareds I should say, and therefore we can put all the r's on one side. So if I take this guy and put it over on that side, I'll get minus 2r plus 2 root 3 plus 1r. And factor out the r, and you'll get 2 root 3 plus 1, like that, and minus 2. And I think this could probably be simplified a little bit further. 2 root 3, 2 minus 2, so that's just 2 root 3. All right, great. And this one was just root 3 plus 1 all squared. So there you go. I've got my answer, root 3 plus 1 all squared over 2 root 3. And I'm certain it's not in this format. Yeah, it's not. So it's another example of a question where you get the answer, but it's not in the format of the answer choices. So we just have to manipulate it to make it into a different format without changing the value, of course. All right, no problem. Let's expand this. 3 plus 2 root 3 plus 1 over 2 root 3 is equal to r. So this looks like 4 plus 2 root 3 over 2 root 3. Time to rationalize the denominator, multiply top and bottom by root 3, and you get 4 root 3 plus 2 times 3, which is 6, over 2 times 3, which is 6. And this looks like 2 root 3 over 3 plus 1. Or 2 root 3 plus 3 over 3. 2 root 3 plus 3 over 3. Let's see if that's there. 2 root 3 plus 3 over 3 is indeed, for number 16, choice D. The two digits in Jack's age are the same as the digits in Bill's age, but in reverse order. In 5 years, Jack will be twice as old as Bill will be then. What is the difference in their current ages? So we've got Jack and we've got Bill, and his age is basically AB. Those are the two digits. And Bill, he's BA, like that. So 10A plus B is the numerical value of his age, and 10B plus A is the numerical value of Bill's age. And they want you to find the difference currently. So the difference currently is going to be 10A plus B minus 10B plus A, like that. And if you do the algebra here, we'll get minus 10B minus A, and this looks like 9A minus 9B, and we can factor out a 9A minus B. So the difference is obviously a multiple of 9, and I see that all the answer choices are multiples of 9. All right, where can we go now? Well, we'll obviously have to use this sentence in terms of a clue. They're saying that in 5 years, so 10A plus B plus 5, Jack will be twice as old as Bill. So 2 times 10B plus A plus 5, like that. Okay? So now let's see if we can solve for this, get a relationship. 10a plus b plus 5 is equal to 20b plus 2a plus 10, like that. So this becomes 19b and this becomes 8a and plus 5, like that. And then I guess you can just isolate for a 19b plus 5 over 8. And then now we have to go back and see if we can get any kind of a value for that, because our answer choices are numbers. So substitute this into there, and I've got 9 times 19b plus 5 over 8 minus b, like that. And then let's see here, get a common denominator, 8 and 8, so 19b plus 5 minus 8b over 8 times 9, and this looks like 11b plus 5 over 8 times 9, and that is 99b plus 45 divided by 8, and that is the difference. 99b plus 45 divided by 8. So unfortunately, even after all this math, we didn't get an actual numerical value. But no problem. We can substitute values of b and see if that works. Does it give us an integer? When b is 0, what do we get here? We get 45 divided by 8. Unfortunately, that's not an integer, right? Because our answer choices were all integers. They were 9, 18, 27, 36, 45. All right, keep going. How about when b equals 1? When b equals 1, we got 99 plus 45, which is 144. And is that divisible by 8? The answer is yes. 99 times 1 plus 45 divided by 8 is indeed a value divisible by 8. You get 18. And there you go, that's the difference. That's what they're asking for. So the answer here, number 17, is B. In the right triangle ACE, we have AC equal to 12, CE is 16, and EA is 20. Points B, D, and F are located on AC, CE, and EA respectively, so that AB is 3, CD is 4, and EF is 5. What is the ratio of the area of triangle BDF to that of ACE? So they want us to figure out the ratio of that to that. So BDF over ACE, correct? Now BDF is this guy in the middle right there. And we could get that if we take the entire triangle ACE and subtract from it 3 other triangles, right? This one, and that one. And I think we can do that, but we will have to figure out a few values first. And I'm going to draw those in. The first one, I'm going to need some help here. The first one is this distance from here to here. That's going to be very helpful. And then the next distance is from F down to the bottom like that. If I can figure out those two, then I should be able to figure out this question. And I will label this X and I'll label this Y. Okay? Now first I'll put in the values here. So ACE, let me see, I've got to subtract this triangle right here. So that's dimensions that I have already been given. So 1/2 base times height, 4 times 9. And then I've got to subtract this guy right here. Okay? So that's a little bit more trickier. 1/2 base, but the base is from here to here, correct? And that's 12. But the height is Y. So as you can see, I'm going to need to calculate y. And then the last triangle I've got to subtract is this guy right here, that one in there. And that one, let's see, the base will be 3. And the height will be x. Okay? And then, of course, that will be all over ACE. Now, ACE we can actually figure out immediately, right? Because we have all the values for the length and width or height and base and whatever. So ACE looks like 1/2 base, which is 16, and times the height, which is 12. And then we'll have to simplify all these. Looks like 2 times 9, which is 18, minus 6y, minus 3 over 2x, all over 1/2 16 times 12. All right, so that basically becomes 8 times 12, which is 96, minus 18, minus 6y, minus 3 over 2x, all over 96. So all we have to do is figure out the values of x and y, and we are all set with this question. So let's proceed to do that. Keep my diagram in the photo here. Now, there's a few relationships, right? The first relationship I see is basically a similar triangles right here. This triangle is the similar triangle to this one right here. All right? And if they're similar in terms of their sides, the ratio of the sides will also be the same. So that means that this side right here, which is basically 12 minus y, over that side, which is x, is equal to this side, which is y, all over this side, which is 16 minus x. And this will be our first relationship, so cross multiply 12 minus y times 16 minus x is equal to xy, and therefore that becomes 192 minus 12x minus 16y plus xy is equal to xy, and therefore we can divide through by 4. I'm going to give you 48 minus 3x minus 4y is equal to 0. And then put 4y on one side, 48 minus 3x, and therefore y is equal to 48 minus 3x divided by 4. All right? So now we need another relationship because we need to figure out actual numerical values for x and y. What numerical relationship can we find now? Well, these are right triangles, correct? And because they're right triangles, basically, we can use Pythagoras. So first, let's do it on this triangle right here. On that triangle, we have the following relationship. You have 12 minus y squared plus x squared is equal to 15 squared. And this little guy here, we've got a very similar relationship. We've got y squared plus 16 minus x squared is equal to 5 squared. All right, so let's expand these, see what we get. So the first one, I've got 144 minus 24y plus y squared plus x squared is equal to 225. Second one here gives me y squared plus 256 minus 32x plus x squared is equal to 25. And I think if we subtract this from that, we should be able to eliminate a lot. So 144 minus 24y plus y squared plus x squared minus y squared minus 256 plus 32x minus x squared. I'm subtracting. So 225 minus 25. And then this looks like it's 200. Here, y squareds are going to cancel. And then you just get left with 32x minus 24y minus 112. Put everything on one side and divide through by, you probably divide through by 8. So this will become 4x minus 3y, and then it will be 312 divided by 8, which is 39. And at this point, we can substitute this guy right here into this equation, and that will help us. It will allow us to solve and get numerical values. So 4x minus 3 times y, which is 48 minus 3x over 4, is equal to 39. And let's see what we get here. Multiply through by 4, and we'll get 16x minus 144 plus 9x is equal to 156, because remember we multiplied through by 4. So this looks like 25x. 156 plus 144 will be 300, and therefore x is equal to 12. And if you plug x equal to 12 back into here, you get 48 minus 36 divided by 4. So that's 12 divided by 4, which is 3. So y is equal to 3. And there you go. We've got it. Everything we need. We'll go back to our formula. X is 12, y is 3. So remember, this was our original x. We got to be 12, y is 3. Well, now we can solve. So 96 minus 18, no problem. 78. 6y, well, y is 3, so 6 times 3 is 18. 3 over 2 times x is 12, so that's 36 divided by 2, 18, all over 96. So this looks like 78 minus 18, which is 42. 42 over 96. And let's get this in lowest terms. Let's see, divide through by 2, 21 over 48. And then divide through by 3. And it'll give you 7 over 16. And I think that's about as low as we can go. 7 over 16 is the answer. And therefore, let's see here. Number 18, 7 over 16 would be E. In the sequence 2001, 2002, 2003, ... each term after the third is found by subtracting the previous term from the sum of the two terms that precede that term. For example, the fourth term is 2001 plus 2002 minus 2003, which is equal to 2000. What is the 2004th term in the sequence? So these are questions that basically involve you writing it all out and then seeing if you can get a pattern. And the hope is that you can get a pattern quicker, sooner rather than later. So I'll just do the first 10, let's say. And then hopefully we can see a pattern after we do the first 10. All right, A1, they actually give you already 2001, 2002, and 2003. And then A4, they also give you, they actually calculated it for you up here. Okay, now let's figure this out. So how do I get a term? I've got to take the previous term, which is 2000, and then I've got to subtract that from the sum of the ones two before it. So 2002 plus 2003. So you see how I did that? So that's how basically you're getting each term. So this looks like it's 2005. All right? So let's keep going. Now I've got to take that 2005 and subtract it from the sum of the ones before it, two of them. So 2003 plus 2000. And this is equal to 1998. All right, let's keep going. 1998 this time. I've got to subtract that from the sum of the previous two, which is going to be 2000 and 2005. And that is going to be equal to 2007. And in a very similar way, just keep going here. 2007, 2005 plus 1998. And this will give you 1996. All right, we got two more to do. 1996. We got 1998 plus 2007. And this will give you 2009. And one more. So 2009. And subtract that from the sum of 2007 plus 1996. And that gives you 1994. All right, so I think that's pretty good. You probably already see a pattern. Basically, it seems like when A5 or A7, whenever you have an odd number for the term, it's giving you 2005, 2007, it's going up like that. And when you're getting even numbers for the term number, I should say, A6, A8, A10, it's 1998, and it's going down 1996 like that. Now, they want the 2004th term, right? So they want A 2004. Now, is 2004 odd or even? Well, it's even. So because it's even, we're going to be looking at numbers like these. Correct? Now, can you find a relationship a to the n when n is even? What will be the term? All right, let's look at this. When it's 6, it's 1998. When it's 8, it's 1996. When it's 10, it's 1994. All right, it seems to be going down by 2. I think it's n minus 6. Well, actually, I don't think that will work. But I think I'm on the right track here. It's 1998 when it was 6, okay? And then it was 1996 when it was 8, and then 1994 when it was 10. Okay, I see what's going on. I believe we started at 2004, and it's 2004 minus n, like that. So it'll work, right? When we have 2004 minus n, when n is 6, it will be 2004 minus 6, which is indeed 1998. When n is equal to 8, it will be 2004 minus 8, which is indeed 1996. When n is 10, it will be 2004 minus 10, which is 1994. All right, perfect. So there you go. That's the conclusion. So 2004, that should be pretty straightforward. It'll be 2004 minus n. n in this case is 2004. Well, that's equal to 0. So our 2004th term is 0. So number 19, the answer is C. In triangle ABC, points D and E lie on BC and AC respectively. If AD and BE intersect at T, so that AT over DT is 3 and BT over ET is 4, what is CD over BD? So several approaches to this question, whatever approach you are most comfortable with. And what I'm going to do in this question is put it on a coordinate axis. And if I do that, I'll be able to explain it very clearly. So I put these points on a coordinate axis, and I'm going to use the exact same dimensions in the question. Obviously, I cannot change the dimensions. This basically will be 1 in terms of its length from the origin to E. This will be 1 from the origin to D. This will be 4 from the origin to B, and this will be 3. from the origin to A. And therefore these points for D is obviously 1, 0. For E, it's 0, -1. For A, it's -3, 0. And finally for B, it's 0, 4. All right, and then I'm going to connect the dots here. So I've got to join B to D, like that, and I've got to keep going a little bit. And then I've got to join the other ones, so A to B, A to E, but I've got to keep going. And the reason I've got to keep going is because there's a C point, and that C point is right here. That's C right there. Right there, that's C. And we want to figure out in this question the distance from B to C. So this distance right here, that distance. So find BC. If we can do that, then we'll be able to find the ratio, which is what they're looking for, CD over BD. So how do we do that? Well, the first thing we'll need to do is find equations for these lines. The line from A to C and the line from B to C. If we find those two equations, we can then figure out their intersection point, which is C, and that will allow us to figure out the distances that we require right there. Okay, so let's proceed. Any equation of a line is of the form y equals mx plus b, correct? So now let's first concentrate on trying to find the equation of this line right here, from A to C. Now the good news is we have 2 points, we've got A and E, and therefore we can do that. So let's first figure out the slope. The slope is rise over run, and the slope in this case would be -1 minus 0 over 0 minus -3, and that is -1/3. So I've got y is equal to -1/3 x plus b. To figure out b, I'll just substitute one of the points. I can just use a. So that means when y is 0, my x value is -3 plus b. So that basically means that b is -1. So my equation for this line from A to C is y is equal to -1/3 x minus 1. Okay? And in a very similar way, let's now figure out the equation of the line from B to C. Well, it's obviously y equals mx plus b in terms of the form. M in this case, rise over run, same kind of story. 0 minus 4 using these 2 points, B and D, all over 1 minus 0, and therefore M is equal to -4. So my equation is y equals -4x plus b. To figure out b, just substitute one of the points. I'll just use 1, 0, this guy right here. So when y is 0, my x value is 1 plus b, and therefore b is equal to 4. So this equation is y is equal to -4x plus 4. So there you go. I've got 2 equations for 2 lines, and now I can find their intersection point, which is C. To find the intersection point, just set them equal to each other. So -1/3 minus x minus 1 is equal to -4x plus 4. All right. Let's see. Multiply through by 3, and you'll get -x minus 3 equals -12x plus 12. And if you bring everything on one side, you'll get 11x is equal to 15, and therefore x is equal to 15 over 11. And then if you substitute back into any of these, you'll get your y value. I'll put it into that one. Doesn't really matter. Either one would work. 15 over 11 minus 1. So minus 15 over 33 minus, get a common denominator. And this looks like minus 48 over 33 which in lowest terms would be minus 16 over 11. So this C is 15 over 11 and minus 16 over 11, the coordinates. All right, so now I have basically everything I need to solve the question. They want the ratio of CD over BD. So I can easily figure out the length of CD. I've got the 2 points. And I can figure out the length of BD. I actually could have done that in the beginning, but now I definitely have enough information. So I'll do that over here. CD over BD, correct? All right. CD over BD. Well, the distance between 2 points, I'm sure you know how to do that. 15 over 11 minus 1 squared plus minus 16 over 11 minus 0 squared. Take the square root. And then BD, that's, let's see, 0 minus 1 squared plus 4 minus 0 squared, all in the square root, right? Just using those 2 points right there and using the formula for distance between 2 points. So this looks like, do some algebra here, 11 over 11, so 4 over 11 squared, like that. And then this is just 16 over 11 squared, all under the square root. The bottom is just 1 plus 16, I believe, under the square root like that. And then this becomes 16 over 121. And this is 256 over 121, all over 17. And this looks like 272 over 121 over root 17. And the top is also under the square root. And you can put this all under one big square root sign like that. 272 over 121, invert and multiply 1 over 17. 272 divided by 17 is 16. So you get that fraction. And then the square root of this, both of these are perfect squares, so that becomes 4 over 11. And that was what? CD over BD. CD over BD. So there you go. After all that, we got 4 over 11. And therefore, the answer to number 20 is D.